In 1939, the world was on the brink of total war. Germany's Luftwaffe was celebrated as the most advanced air force in Europe, its Messerschmitt Bf-109 fighters and Heinkel bombers dominating the skies. German engineers were proud of their machines, confident that steel and magnesium alloys provided the strength and durability necessary to win any dogfight. Across the Atlantic, however, American engineers were quietly experimenting with a radical idea. What if warplanes didn't need to be heavy to be effective? What if the future of aerial combat relied on aluminum, a lightweight, seemingly fragile material that could be turned into powerful, deadly aircraft? The Germans scoffed at the concept. They called it toy metal and laughed at the idea that such delicate machines could survive a real war. They were confident that American planes would never make a mark in the European theater. But the Americans had a different vision. They understood that war was not just about the strength of a single plane. It was about speed, maneuverability, range, and the ability to produce planes faster than they were lost. Engineers at Boeing, Lockheed, and Republic poured their expertise into developing aircraft made almost entirely of aluminum alloys. These metals were carefully engineered to be both light and strong, allowing for faster planes with longer range and greater firepower. It was a gamble. Aluminum was cheaper, easier to work with, and allowed for mass production. But skeptics in Germany, and even some in the United States, doubted whether these planes could survive in real combat. The stage was set for a shocking revelation that would redefine aerial warfare. By 1941, the American aircraft industry was operating at full speed. Factories hummed with the sound of assembly lines, producing wings, fuselages, and engines at an unprecedented pace. The P-47 Thunderbolt, famously nicknamed the Jug, emerged as the first real test of America's aluminum gamble. Equipped with a powerful radial engine and 8 50-caliber machine guns, the P-47 was deceptively fast for its size. Its aluminum frame allowed it to reach speeds over 400 miles per hour while carrying bombs or rockets, giving pilots a combination of firepower and durability previously thought impossible for a plane made mostly of light metal. Meanwhile, the P-51 Mustang, a sleek, elegant aircraft with an all-aluminum fuselage, became the ultimate escort fighter for American bombers. With its long range, it could accompany bombers from England to Berlin and back, something the Luftwaffe could not prevent. When these planes finally reached European skies, German pilots were stunned. Their Messerschmitts and Focke-Wulfs, once untouchable in dogfights, could not match the speed, climb rate, or firepower of the Thunderbolt and Mustang. Reports from Luftwaffe pilots described the shock of seeing American planes effortlessly outrun their fighters, their formations shredded by machine gun fire, and their strategic advantage evaporating. One German ace famously said, "When the Mustangs came, the war was lost in the air. What had once seemed a weak, toy-like plane had become one of the most feared weapons in the sky." The impact of aluminum planes went beyond speed and maneuverability. They allowed the United States to exploit its greatest advantage, industrial capacity. While Germany struggled with fuel shortages, material rationing, and the constant strain of war, American factories could churn out thousands of aircraft per month. Aluminum, abundant and easy to work with, became a critical resource that allowed the Allies to maintain relentless pressure on the Luftwaffe. The skies over Europe were no longer the domain of a few elite German pilots. They became the stage for an industrial war, where the sheer number of planes and pilots could overwhelm even the best-trained enemies. Bombers like the B-17 Flying Fortress and B-24 Liberator, made primarily of aluminum, could sustain heavy damage and still complete missions. Entire formations of these planes, escorted by P-51 Mustangs, struck deep into Germany, devastating factories, supply lines, and morale. The irony was profound. German engineers who had once mocked aluminum as a weak, insignificant metal were forced to confront the very reality they had dismissed. They walked through bombed-out factories and airfields, witnessing the planes they had once laughed at tearing through the skies with devastating precision. What they had assumed was a weakness, lightness, flexibility, and reliance on a metal they considered fragile, had become the very reason for their defeat. Aluminum allowed American planes to be fast, strong enough to survive combat, and numerous enough to dominate the war in the air. It was a combination of engineering genius and industrial might that Germany could not match. The story of America's aluminum planes is not just a tale of technology. It is a story of innovation, vision, and strategic thinking. While the Germans relied on brute strength and traditional approaches, the Americans embraced a new philosophy. Adaptability, speed, and mass production could outmatch raw power. This approach not only changed the outcome of aerial combat, but also helped pave the way for the eventual Allied victory in Europe. From the P-47s and P-51s to the bombers that could reach Berlin with precision, aluminum became the backbone of America's air supremacy. By 1944, the skies over Europe had been irrevocably altered. Waves of American bombers, supported by agile aluminum fighters, decimated German industry and air defenses. The Luftwaffe, once the pride of the Reich, was unable to replace losses quickly enough. German pilots and engineers were left stunned, realizing that the planes they had mocked were now the instruments of their defeat. The lesson was clear. In warfare and in life, strength is not always measured by weight or steel, but by vision, innovation, and the courage to embrace the unexpected. When the war finally ended, the legacy of America's aluminum planes endured. They were remembered not only for their performance, but for the paradigm shift they represented. The engineers who had doubted them had learned, often too late, that sometimes the lightest metal can carry the heaviest burden of victory. And for the pilots who flew them, these planes were more than machines. They were symbols of ingenuity, courage, and the power of thinking differently in the face of overwhelming odds. The aluminum airplanes that once elicited laughter had become the very instruments that won the war in the skies. In the end, the story of America's aluminum planes is a lesson in humility and innovation. It reminds us that underestimation can be fatal, that new ideas can challenge established norms, and that brilliance often comes in forms that seem fragile at first glance. German engineers mocked them, but history remembered them as heroes of the air, lightweight, fast, and unstoppable. And so, in the crucible of World War II, aluminum, once dismissed as insignificant, rose to prove that sometimes the smallest advantage can change the course of history.